Right, in the next part, we'll look at exponential expressions, but where we have addition and subtraction involved. Now, when you're given these types of questions, it may seem impossible to solve. However, if we re-represent all numerical bases into prime bases, we will be able to simplify the question. So when we're dealing with addition and subtraction, we will make use of factorization. How do we factorize? Using HCF. But in terms of exponents, it means that we have the same base and the same exponents. That's exactly what we call a like term under the algebraic expressions course. And that's what we call a like term. If the base and the exponent is the same, then we have a like term. So that's how we take out our HCF. So let's look at this question here. All right, so let's do this. 4 to the power x minus 2 to the power 2x plus 2. So that's the first step, is to convert. So it'll be 2 to the power 2 times raised to the power x minus 2 to the power 2x plus 2. Then distribute. This will give you 2 to the power 2x minus 2 to the power 2x plus 2. Then we separate. So there'll be 2 to the power 2x minus 2 to the power 2x times 2 squared. Therefore, what we have now is this and these are two like terms. So they are the same term. They are common terms in the expression. So therefore, we can factor it out. So we'll have 2 to the power 2x into 1 minus 2 to the power 2. And lastly, it should give us minus 3 times 2 to the power 2x. That's how we solve the question. I convert, distribute, separate, and solve. Now let's look at this one here, a bit more complicated example, but we can solve it. Right, so now what we have here is, so we have 4 to the power x minus 2 to the power 2x plus 2 over 2 to the power 2x plus 3 plus 2 to the power 2x. Initially, the first time I see this question, I already know that this, and this will cancel. So I already know I'm going to get rid of the variables, right? And I know I'm going to get a numerical answer. But if I solve it systematically as I taught you, the first step is to re-represent. So it'll be 2 to the power 2 raised to the power x minus 2 to the power 2x plus 2 all over 2 to the power 2x plus 3 plus 2 to the power 2x. So now we have 2 to the power 2x distribute minus 2 to the power 2x plus 2 all over 2 to the power 2x plus 3 plus 2 to the power 2x. Right. Now, after we distribute, what we must do, separate. So it'll be 2 to the power 2x minus 2 to the power 2x times 2 to the power 2. I did not change the question. I re-expressed it. It'll be times 2 to the power 3 times 2 to the power 2x. So therefore, we'll have 2 to the power 2x into 1 minus 2 to the power 2 all over 2 to the power 2x into 2 to the power 3 plus 1. This and this will cancel. So therefore, we are left with 1 minus 2 to the power 2 gives us minus 3. And 2 to the power 3 is what? 8 plus 1 is 9. So therefore, we're left with minus 1 over 3. Exactly as we solved it here. Now, this is a very, very, very important question. Why? Because after we've done rational expressions, I've talked about a restriction type question. And since I see a fraction, it means the denominator cannot be 0. This is something that I will discuss with you at grade 12. Very, very important. But for now, just take the question as it is. But I can promise you at university, these ideas will become very important. For now, I'm telling you that there's no restriction, right? Because there's some ideas here that we haven't even delved into functions with you yet. But when you delve into functions, it gets very, very interesting. That's like one of my favorite sections. So for now, let's not even think about it. And if you look at this one here, we are somewhat making use of U substitution, right? But you have to just see something here. See 2 to the power 2x minus 1. You can be re-represented as 2 to the power x raised to the power 2 minus 1. Now we have a difference of 2 squares. So it'll be 2 to the power x plus 1, 2 to the power x minus 1 over 2 to the power x plus 1. So therefore, that and that will cancel. So therefore, we'll have 2 to the power x minus 1. Again, here, this is a fraction. The denominator cannot be equal to 0. But I am telling you, this question has been structured out in such a way that the denominator will never be 0. Right? If you understand what I wrote here, then that's good. If you don't, we will talk about it when we get to functions. Right? But the restriction is supposed to be stated here. There is no restriction. Even here and here, there's no restrictions because the question has been intentionally written like that. So there's nothing for you to even actually worry about. But I'm saying in the grand scheme of things, when you're actually working at university or at grade 12, it's very important that you do state the restrictions. right? So there's nothing in maths that we leave untouched. Everything that we speak about in maths matters. So you make sure that you understand everything fully. Okay, now that's basically everything that we need to know. We've done the multiplication, we've done the division, we've done the addition and subtraction, and we've also done some of the rules that we need to talk about. So lastly, we'll talk about the rational exponents and move forward from there.